But how far can it go before we can no longer communicate with it? To answer this, we need to know how Voyager 1 receives and transmits data from 21 billion kilometers away. A 20 kilowatt signal is transmitted from Earth to Voyager 1 using radio waves. It takes almost 20 hours for the signal to reach the space probe, where its sensitive antenna picks up the signal. For comparison, it takes the rovers on Mars an average of just 15 minutes to send messages back to Earth. Voyager starts sending data back to Earth using a 20-watt signal. As it travels through space, the signal strength weakens, and by the time it reaches Earth, the signal is barely detectable. In order to communicate with objects that are this far away, it doesn't really matter how strong the signal is, as long as you have a receiver that is sensitive enough to pick it up. NASA uses the Deep Space Network, which consists of 3 antenna complexes equally spaced around the Earth. Each complex has a huge 70-meter antenna, along with multiple 34-meter antennae, which can be combined to pick up signals that are thousands of times weaker than your standard FM radio signal. The Deep Space Network spends several hours each day listening to faint signals from Voyager 1, and so far, it continues to talk back to us. Since our methods of detecting signals has improved drastically over the past 50 years, there isn't really a limit on how far we can communicate with objects in space.